Okay, so we are back and we are going to move on to the second lesson, which is 1.2, and we're going to solve systems of linear equations using the substitution method with two learning targets. One, that you can solve systems of linear equations with two variables using the substitution method. And then the second is that you can solve real life problems using systems of linear equations. And, that is a target that we're going to develop over the multiple sections and as we go through. Now, as you recall from the previous lesson, what we would do is we would find points of intersection, right? We would graph two lines and then we would find an ordered pair here. So I have a line here in black and a line here in red. And my solution is this circled point that's in blue with an x value and a y value here. And we could verify that it was a solution by taking our x value and y value, plugging it in, and seeing if it balances the equation. Okay. Now, technically what we're doing is going to be the exact same thing. The only difference is instead of graphing, we're going to use an algebraic method. Okay. Now, these methods tend to be a little bit more useful in comparison to the graphing method, because if you recall, when we got to some of the word problems that we did, is, sometimes we had points of intersection that were not going to be whole numbers, such as the bottom one with milkshakes and sundaes. We would have intersected at 2.5 and 2. Okay, and we would have had a y-intercept of 3.25. And those are hard to graph accurately without scaling your axes properly. And so this is a method that is extremely useful to us. Okay, so let's just kind of go over some brief things about substitution. Basically, substitution is like, for example, we've used this actually last time that we had class. So, like, when I know what x is equal to, I can just go and replace all x's with whatever number it's equal to. So if I knew x was 5, I can plug in all x values of 5, and that will help me solve. That concept is going to be consistent here in this method. The only difference is we're not going to know exactly what number x or y is equal to. But then once we know what it's equal to, though, we can go ahead and plug that in, and it will help us find an x or a y value. So let's go ahead and get started. So the first one here is y is equal to 2x and 4x minus y is equal to 6. So again, I'm looking for the x and y ordered pair that I can plug into both of these equations, and it's going to balance out the equation. Okay, and at the same time. So this is my system. And what we want to do is we want to look and ask ourselves, at any point, do we know what x is equal to or y is equal to? Well, I may not know what number x is equal to or what y is equal to, but I do know that y is equal to the expression 2x. So I know that the value of 2x is what y is equal to. So this one's already kind of set up nice and neat for us, right? Y is already by itself. It tells me y is equal to 2x. So what that allows me to do is I can go ahead and plug in 2x for all y's in the other equation. So I can go ahead and I can just replace the y right here with 2x. So let's go ahead and see what that looks like. So now I am going to rewrite the bottom equation. But instead of y, I'm going to write what y is equal to. Y is equal to 2x. Okay, so now I have 4x minus y, this is y, is equal to 6. Okay, and then from that point on, I can just simplify. So 4x minus 2x's, so I have 4x's here, I have 2x's there. I'm looking to subtract two of them. So 4x minus 2x is 2x. And now I just have to solve for x. 2x, at this point we should know, already implies that it's 2 multiplied by x. So if I want to undo a multiplication of 2, I would divide. Okay. And so this is just an application of the substitution property. That's why we call this the substitution method, because it's using the substitution property just to plug in and go. Okay, so now I know what x is equal to. Well, I still have to figure out what y is equal to. So now at this point, once you figure out, like here, once I know what y is equal to, I can't take the 2x and just plug it back into itself. I have to plug it back into the other equation. Here at this point, it really doesn't matter what method or which equation you're going to use to plug x back into. If you solve the first part correctly, you should get the same answer either way. I'm going to use the top one here because the y is already isolated, so it's going to be nice and easy for me to plug x into. So I'm going to just take y is equal to 2 times x. Well, what is x? X is 3. Alrighty. And then I just have to go 2 times 3. 6. So right now, I believe my ordered pair is the ordered pair 3, 6. Okay. So we should just get in a good habit of checking our work. And so let's go ahead and do that. Let's say we can check the first one. So I'm just going to check my work in blue so we can kind of see that, you know, this top part is me actually doing the problem. The bottom part is me checking to see if my answer works or not. Now, I showed you how to use the calculator in the previous section to check your work. By all means, I would encourage that, and I think that's a great method. You should get used to the calculators. I'm just going to do it by hand today because it doesn't really take that much extra work, and it's just good practice to at least see it. When you're doing this, feel free to check your work with either the calculator or by hand. Okay, so here I know that y, which is y should be 6. So I'm going to take this top equation and I'm just going to rewrite it. I'm going to say 6 is going to be equal to 2 times 3. Okay, and you may already see at this point that this is going to work. Okay, but so 6 is equal to 2 times 3. Let's simplify this right hand side. So I get 6 is equal to 2 times 3 is 6. Okay, so that works. So that means that 3, 6 is indeed a solution to the top equation. But for a ordered pair to be a solution to a system, it doesn't just have to be a solution to one of the equations. It has to be an equation to both. So we need to go back in and we need to check the other one. Okay, and we can basically do the same thing. We just have to, you know, looks like it's just going to be a little bit more work, which won't be too bad. So x is 3. Okay, and then I'm going to go minus, and then 6. Okay. And that's going to be equal to 6. Okay, so now we just have to simplify. Okay, so 4 times 3 here. 4 times 3 here is 12. Okay, and then 12 minus 6 is indeed 6. And that checks out as well. So what does that mean? So I get 6 is equal to 6 and 6 is equal to 6. They both balance out. That's the key part, is that the equations are balancing out to the same number on each side. Yes, they both happen to be equal to 6. That doesn't necessarily have to be true. Okay, so this is indeed my solution. Okay, this is indeed my solution. We not only found it algebraically using the substitution method, but we also checked and verified that it indeed was my solution. Okay, so if you haven't figured out the pattern yet, what I would like you to do is pause the video, move on to A, which is just off to the right, and go ahead and try that one on your own. Okay, so I'm assuming at this point you've already paused the video and you have tried A on your own, and now you're just here to check your work. Okay, so I'm looking at this and I'm looking for what x is equal to or y is equal to. So as I look at this, it's pretty laid out nice and neat for me that y is just equal to negative 3x. So I'm going to go ahead and I'm going to box that in because I know that's what y is equal to, and I'm going to replace it in the other equation, y in the other equation with that. Now, it's important to note that, yes, these first two examples have just had the y isolated, but that's not always the case. It will about half the time also be x or whatever other variable you are using. Okay, so let's go ahead and rewrite this top equation now and get 2x plus, well, instead of y, we are going to write negative 3x, okay? And anytime you're going to have like a plus, a negative like that, I actually think it's helpful to just go ahead and put parentheses around it. So I'm going to go ahead and do that, and then that's equal to 3. Okay, so now I have to figure out what 2 plus a negative 3x is. So we have, you know, if you know when you're adding your positives and negatives, one positive will cancel out with one negative. So I have 2 positive x's here and 3 negatives here. So you need to think about how many more negatives are here in this 3x than there are in this positives in this 2. Well, there's one more negative here in this negative 3x than positives in this 2x. So this is going to simplify into negative 1x. That's equal to 3. Okay. So negative 1x is equal to 3. Okay. We need to know that negative 1x means negative 1 times x, and so we're going to divide by negative 1. And now I get x is equal to negative 3. Okay, so there's my first part of my answer. Now I need to find the other part. And you can plug it into either equation, but realistically, it doesn't matter. I'm going to pick the bottom one again, because since I will be solving for y is already isolated, so it's going to be the easiest work for me. Okay, and so we know y is equal to negative 3 times negative 3. Okay, so y is equal to negative 3 times negative 3 is positive 9. And now I just need to check my work. Okay, I'm going to take that first equation here. First equation, I'm going to replace y with 9. And it's going to be equal to negative 3 times negative 3. Okay, so then this is equal to 9. And then negative 3 times negative 3 is positive 9. So okay, this checks out. This is the ordered pair negative 3, 9 is a solution to the bottom equation, but it's not a solution to the system until we know it's a solution to both. It has to be a solution to both. Okay, so let's go ahead and test the other one out. So I'm going to have 2 times x, which is negative 3. All right, and this is plus y, which is 9. And that is going to be equal to 3. Okay, 2 times negative 3 is a negative 6. Okay, and then I have negative 6 plus 9. Okay, and so to be able to do this in your head, we know that when we're adding positives and negatives, that every one negative will cancel out with one positive to 0. So there's 6 negatives here and 9 positives here. So how many more positives are in this 9 than there are negatives in this negative 6? Well, there's 3 more positives, so that's what they're going to cancel out to. So this is going to be 3 is equal to 3. So these balance out. And again, as I was talking about here, they don't always have to balance out to 6 here, as long as the equations balance out. Yes, this one balanced out to 9, and this one balanced out to 3. But the fact is that they balanced out, so that indeed makes our solution of negative 3, 9, the ordered pair. That is the solution. All right. Okay, so this is the very core basic type of problems that you're going to be seeing and getting. The ones that you're probably more than likely going to see on tests and such are going to be have just a little bit extra work, and they're going to look more like 2 and B. So 1 and A, we're really just laying the ground level work for us, but these are the ones that you're going to need to be able to do for assessments. Okay, so here I want to use a substitution method as well. I have 3x plus 2y is 7, but also that x minus y is equal to 6. So as I'm looking at this, it's not really laid out like the other ones. Let's look at the other ones. The other ones, like one of the equations, just y was already by itself. Or it could have been, it was not in this example, could have been x was by itself. But when I look at these ones, that's not the case. Okay? So, as I look at this, we want to be able to get one of the variables by itself, and then all we have to do is plug it into the other equation. Now, you can technically pick any variable and any equation, and your work's going to get out fine. But one thing I think that would be helpful for you all is to think about like what equation is actually going to require the least amount of work to get the variable by itself. Okay, so let's just think ahead and think out loud. So if I wanted to get this x by itself in the top equation, I would have to subtract 2x and then divide by 3. Okay, so about 2 steps. 2 steps and I'm going to get x by itself. Not too bad. You could do it. And it really wouldn't be that much extra work. But let's look at the x down here. Okay, this is just a positive 1x. So if I want to get this x by itself, all I'm going to have to do is just add y. I add y to each side. The y's cancel out over here on the left, and there will be 6 plus y on the right side. Well, that's just one step, and the x is by itself. So this variable in this bottom equation is the one that we're probably going to be looking for to use. Again, you can pick any variable in any of the equations, and you're going to get there. It's just you want to think about which might be the path of least resistance. You may also think about the y. Maybe I want to get the y by itself. Well, all you're going to have to do is subtract x. But then you have negative y here, or the opposite of y. And then you'll have to divide by negative 1. So even then, that's 2 steps. So really what you're looking for is positive x or positive y. And those are the ones you're going to want to try to isolate. So I am going to pick the bottom equation. And I'm going to pick the x variable. So how do I get the x variable by itself? I'm going to add y to each side of the equation. And I'm going to get x is equal to 6 plus y. Okay, so now I know what x is equal to. Now these problems are no different. I have x by itself. I know what it's equal to. You just got to make sure that you're taking the entire expression that x is equal to, 6 plus y, and plug it into the other equation where the x is. So I'm going to take it and I'm going to replace it right here. Okay, notice that when I drew my little line with the little circle, that little circle is only covering up the x. And that, in fact, it's not covering up the 3x, it's covering up just the x. And that's because I'm not substituting out the 3x, I'm substituting out the x. So that's very important and something that you're going to need to pay attention to. So let's see what that looks like. So I have 3 times x, and x is 6 plus y. Okay. So that's my substitution, right? I got my variable by itself, and now I've substituted. Okay, so let's go ahead and continue forward. Okay, so now we have 3 times 6 plus y. Now you're going to need to remember the distributive property, which is going to multiply 3 times 6 and 3 times y. Okay, so 3 times 6 is 18, and 3 times y is 3y. And then everything else basically can just be brought down as is. I really just haven't done anything with it. Okay, so then the next thing I'm going to have here is I have a 3y and a 2y together. So 3y and 2y together, well, they're both positive, so I can simply add. Those are going to combine together into 5y. Okay, and so at this point here, I'm just going to need to subtract 18. Okay. Then negative, I believe it's 11, right? So how many more negatives in this 18 than positives in this 7? Well, there's 11 of them. Okay, and then we divide by 5. Okay, this one would come out to a nice... or this one would come out to a decimal that we could just use as a decimal. I'm just going to use negative 11 over 5. I actually have a preference for fractions, okay? And so, because they're always exact, sometimes decimals are not. Okay. So, from there, we just have to go ahead and plug in the y variable. Okay, and really it doesn't matter which one we do, so let's just do the top one. So I'm going to have 3 x, I accidentally put parentheses there, plus 2 times negative 11 over 5 is equal to 7. Okay, so 3x. Okay, so then here, 2 times negative 11 over 5 is going to be negative 22 over 5 is equal to, and what I'm going to do is I'm going to replace 7 with it written as fifths. Okay, so I can have 7. Okay, so I want to have to put this in a form, so this will be 7 over 1 times 5 over 5. Okay, because 5 over 5 is just 1. And I want it in fifths, so I can add. So I get 35 over 5. Okay. Okay, and then I can just add 22 over 5. So now I get 3x is equal to 22 and 35. Okay, so when I add here, we know we're just going to have something over 5. But 35 and 22, so 5 and 2 is 7, 3 and 2 is 5, so 57 fifths. Okay, so now let's talk about 3x. Normally, we would say, how do I get the x by itself? Here I would just divide. I would divide by 3. Well, it's going to be nice to also know that dividing by 3 is the same as multiplying by 1/3. Okay, now this is helpful in this situation because I'm dealing with fractions. I don't want to take 57 over 5 over 3. I could just multiply by 1/3. Okay, multiplying by 1/3 and dividing by 3 are the same thing, so these cancel out here, and I just get an x left over. Okay, and then I have 57 over 15. Okay, so let's simplify this. I know that 60 divides by 3, and 57 is just 3 less than that. So I'm pretty sure that this fraction can be simplified. So let's go ahead and take 57 and divide it by 3. And I get 19 over, and then 15 divided by 3 is 5. Okay, so then I know x is equal to 19 over 5. Alrighty, so this one, although it seems like it required a lot more work, really the concepts are the same. We're just doing a little bit of fraction work to get us back with that. Okay, so let's go ahead and check our work. Let's use a calculator this time. Okay, so I'm going to take the top one, 3, and then instead of x, I'm going to put 19 over 5. And then I'm going to add to it 2 times negative 11 over 5. And I get 7, so that balanced out. Okay, and then let's do the same thing for the other one. Okay, so I have 19 over 5 minus, and then negative 11 over 5. And it balances out to 6. So this is indeed my solution. Negative, or 19 over 5, comma, negative 11 over 5. Okay, so pause your video and go ahead and try letter B on your own. All right, so I'm assuming that you've already paused the video and now you're looking to check your work. Okay, so the first step is trying to figure out which variable is going to be best to get by itself. And if as we look at this, we have just plain Jane x here in the bottom equation, so I'm going to get that x by itself. So I now know that x is equal to 1 minus 2y. I'm going to replace the x there. So I'm going to replace x with 1 minus 2y. And then I'm going to distribute. 2 times 1 is 2. 2 times negative 2y is negative 4y. Okay, these combine to negative 1, so I have 2 minus 1y equals 4. And I'm going to subtract 2. And then divide by negative 1. So I know y is equal to negative 2. Alrighty. So then I want to check to see what x is equal to. So I'm going to take the top equation, or the bottom equation again, I think. Is equal to 1, and then x is minus 4 is equal to 1, because 2 times negative 2 is negative 4. And I'm going to add 4 to each side. So x is 5. Okay, let's go ahead and check to see if that's our solution using the calculator. Okay, so top equation, we are going to go 2 times x, which we believe to be 5. And then we're going to add to it 3 times negative 2. And I get 4, so that's good. And then the next one, I'm going to take 5 plus 2 times negative 2. And I just have to see if that balances out to 1, which it does. Okay, so that means my solution is 5 comma negative 2. Okay. Okay, so we just have one more problem, actually, and then that is it for the substitution method. Okay, one thing I think is important to notice is that this would be a type of problem that would be very, very difficult to find this solution here had we graphed it, and this is why we have alternate methods. Okay, so as we are going to work on a word problem. All right, so one day, the Henry Ford Museum in Dearborn, Michigan admitted 4,400 adults and students, so that's combined adults and students, and collected $57,200 in ticket sales. The price of admission is $14 for an adult and $10 for students. How many adult tickets or how many adults and students were admitted to the museum? Okay, so this one, let's go ahead. The question being asked, how many adults and students were admitted? That can be our variable. So we can say x is going to represent number of adults. And we can say y is going to be number of students. Okay, it's important to know what our variables mean because they help us write the equations. They help us analyze our answers. So let's think about some facts. I know that the first fact that tells me is that there's 4,400 adults and students admitted. So that means if I pile up all my students and I pile up all my adults together, altogether there's 4,400. So what would I have to do with my adults? Like, how many people do I have? Well, I have 4,400, and that's equal to if I add up my adults and my students together. That's our first equation. The next one is kind of talking about money, right? Because it says they collected 57,200 tickets in sales. So if I have $57,200, I know that's equal to the amount of money for the money off of adults I made, and if I add to it the money off of students. So the amount of money I made off adults, well, I take, the amount that I'm charging them, so $14. And I multiply by the number of adults. Because if I only have one adult, I'm only going to get $14. 14 times 1. If there's 2, I'm getting 28. 2 times 14. And then the same concept can work for students, but with y. Okay, so now let's go ahead and use the substitution method. Again, I'm going to show you all the different methods, but when you get to word problems, I really don't care how you solve them. Okay, so let's get the x or the y by itself here. So 4,400 is equal to x plus y. Let's go ahead and get the y by itself, I guess. 4,400 minus x is equal to y, and this equation makes perfect sense. If I have 4,400 and I take away the number of adults, that's going to be equal to the students I have. Okay, and then I can go ahead and replace this here. Okay, so then I am going to have, just move on down just a bit here. I'm going to have 57,200 is equal to 14x plus and 10 times 4,400 minus x. Okay, so then I can distribute here. Okay, 4,400 times 10 is now 44,000. I have 14x and negative 10x. There's 4 more positive x's here. And then I got to get the I got to get the 4x by itself by subtracting 4x. And I'm going to get $13,200 is equal to 4x. And then divide by 4. And I can just take this button and actually, I don't have to retype. If I just hit divide, it will take my ANS, stands for answer, so it's going to take my previous answer here. I can divide it by 4. So 3,300 is equal to x. So what does this mean? Well, we said x is adults, so that means there are 3,300 adults. Okay, so now that we know that there's 3,300 adults, we can go ahead and plug it into, I'm going to use the top equation because I believe it will be the easiest. And 1,100 is equal to y. Okay, and so now I believe that there is 1,100. So let's go ahead and check our work real quick. So I believe that if I take x 3,300 and I add to it 1,100, I should get 4,400. So that's the top one. And then if I take 14 times x, which is 3,300, and I add to it 10 times 1,100, I should get 57,200, which I do. So this means that I just have to write my answer. There were 1,100 students and 3,300 adults admitted. Alrighty. So that is the lesson. So at this point, what I think you all should do is go ahead and move on to the 1.2 homework, and I will see you next time for the elimination method.